Okay, now welcome to question 7b, part 3 of the 1998 paper. In the top right corner here, I've told you to watch in HD. Well, that's going to be the top left. The writing will get small sometimes, and it just helps you out to understand it a bit easier. So part 3 asks us to use part I and double I to express sine inverse 2x minus 1 plus the square root of x for x between 0 and 1. So what does that mean? Well, sine inverse 2x minus 1 is simply bound within that for us. So what are we going to do? So we're going to have to consider part I and double I. Well, from part I, we find the integral of this is equal to 2 sine inverse of square root of x plus c. And in part 2, we found that the same thing is also equal to c. So we're going to equate these because they're from the same integral. So from part I and double I, we'll say that dx over the square root of x, dx over, okay, so something is equal to itself. That's the most obvious thing you could probably state, but that's going to help us because now from I, we know that that's equal to 2 sine plus c. Okay, and from part 2, we also know that that's equal to sine inverse 2x minus 1. And then we're going to have plus k instead of c, because if I put c there, then that would mean it's mathematically not true. We're not going to use that, okay? Because c and c wouldn't cancel out and would say that those two things are identical. But clearly they're not, okay? So I'm going to use k side. C minus k, that's another constant. So I'm going to call that constant a. So when I take c to the other side, I'm going to get k minus c, which are two constants. So if that's a constant on its own, we can call the whole thing plus a. So now we just need to find our constant a. And what does that mean? It just means substituting a value in. Okay, so because we're dealing with x between 1 and 0, for convenience, I reckon we should substitute x is equal to a half. And we'll see where that will take us. So we've got 2 sine inverse a half, and now that's equal to sine inverse. Now 2 times a half is 1, 1 minus 1 is 0, and that's plus a. So simply what we've done here is we've let x equal to 1 half. Sine inverse of 0 is 0. Okay, so now we're going to be left with 2 inverse 1 over the square root of 2 is equal to, is your constant. A is equal to 2 times sine inverse 1 over root 2. Okay, so I'm going to rub out this now section of the board. Okay, so from our agreements in part I and part double I, and equating them, we've now learned that 2 is equal to sine inverse 2x minus 1 plus now our a. So our a is now 2 sine inverse 1 over root 2. Okay, so now all I have to do now is bring this over to the other side. Inverse 2x minus 1 is equal to, because they both share the 2, I'm going to take 2 out, and that will be equal to sine inverse square root of x minus inverse 1 over root 2. And that's pretty much how you do that question. Now, you know how to do the angle formula where you know the difference of two sine inverses. You can let them be equal to a and b and then consider sine a for triangles. But for convenience, we're going to leave it like that because it asks us sine inverse square root of x. And that's how you do the question. 7b is officially complete.